guess one of the relevant things in my curriculum as well is that I know João Paulo for longer than most people here, except Renato. And in fact, since everyone sharing how they met João Paulo, I can also share how I met him and Renato, by the way. I was studying computer engineering back in Brazil, where I now work, and together with João Paulo and Renato, we founded the NEMO research group. But back then I was a graduate student in computer engineering, and João Paulo was studying computer science together with Renato, and we were in a classroom, learning about all kinds of peripherals and interfaces. So like serial ports and parallel ports, and what's the difference between them. And João Paulo was not interested at all in that. I was a computer engineer, was really keen to learn it, but he was not interested at all in that. He was already, looking at thinking about more abstract stuff. And he was actually thinking of Renato, because they were disrupting the class by flirting with each other.
Well, it worked.
It works, love works. So, so I had then the pleasure also to, share our time here in Twente with João Paulo, to share the room with the office with him, and learn all the kinds of things that he was talking about. Real world semantics. There was also very important keyword around here in Twente, which was architectural semantics, which this is Martin Sinner and Luis were here, which inspired also this idea that organizations should have some real world semantics behind them. It should mean something. And then we have here the title of this symposium, Ontology, Semantics, and Intelligence Augmentation, that reflects this journey. When he disappeared to Italy, because at some point in time we had to put posters, because he was a PhD student here, but he disappeared from the hallways of the Zilverling. So we had to put posters wanted for João Paulo, but he was in Trento, drinking good wine and drinking from the philosophy sources that we found already. So I have a very difficult task here, not only because I'm the guy keeping you from lunch, but also because I have to explain how an equal is wrong and how is wrong. But I will agree with a lot of things, but I'll just show specifically where we disagree. And for Barend, I completely agree with respect to the scale and the key of your message. But at the same time, I disagree that there can be no precision, or that we need data quality. So, and I'm sure that
there can be no perfect precision.
Yeah, and I'm sure that you will that it can only be reusable if it has some kind of minimal quality. And what we have been seeing is very worrying. For example, in this platform, Wikidata, which shows some examples, but there are examples in Archimate specification, there are examples in UML specification, in UML models. And so I will show you some examples of problems that we get when we do not think about some very basic sanity checking for ontological or even logical principles, and show you some examples of what's going on in Wikidata specifically, which is a very interesting source of empirical data for us, because there's a very large knowledge graph that people are trying to build with a very large taxonomy as well, with physics assumption and instantiation, as we just heard. There are problems, and I hope to show you some of these problems, and also to show you that if we have a little help from simple theory, and even some simple axiomatization with some theorems that we can prove from that, which I'll not show here, but they can be implemented, and we can get rid of all the logical problems just using the results and putting syntactic constraints in place, writing simple queries that will show you how the representations fail to respect some basic sanity checking rules. So this is work that I've been doing for a while with this group that I wanted to acknowledge. Students that work with us, some here, is around, so we've been looking at this issue of multi-level modeling when classes and types are also in the domain of inquiry, and this is something that falls into this wider context of this conceptual modeling that Nicola so nicely introduced with also the definition of John locals. What we care about is that we produce some symbolic structures, even databases or platforms like Wikidata or models like the Mapas diagrams or semantic web artifacts or whatever, knowledge graphs that have some meaning, that capture some statements that are relevant for us. And the value of these structures is about what they encode in terms of information, what we can uncover in terms of relationships, what we can infer from the statements that are embodied in some way. So this is because there is no telepathy, at least not yet. So we need all these symbolic structures, and we're using that to communicate. And this is usually done in terms of conceptual modeling tasks. This is usually done by coming up with a series of types or classes and their relations and features that they have at the conceptual modeling level. Typically the focus of a UML or ontology efforts and so on, and then later instantiating the classes that you have either in a running system or in a concrete representation like Wikidata or some other knowledge base. Normally, we live in this two-level world. So we have here the schema and we have the instances. And in some cases, things get a bit more interesting and complicated when we have not only to talk about the instances or objects and individuals, we talk about the classes or the types or whatever. So we talk about things like Brazil being a country, Bahia being a state, and so on. But we also talk about these things here, the classes and the types, with other classes and other types. So this is the multi-level perspective. We will be on two levels. You do this for a number of reasons. If you look at concrete knowledge bases, this happens a lot. So this is a massive phenomenon in Wikidata, that you have types of types, and even types of types of types and so on. So we have to understand this and be able to come up with the minimum quality for this kind of language, which is what we're trying to do. And this happens for a number of reasons. One of them is that, we cannot be specific. We have to theorize about the types themselves. Because, for example, here we have the specific types of administrative territorial entities in Italy, which are different from Brazil, and we have to have all of them there, and we have to have some general rules about how to introduce new territorial entity types into a system. So we want to talk about the relations that they can establish. We want to capture the general invariance that in particular countries, there are these rules that will appear at the individual level, but they are established at a very general level at this second order level here, where you have the types of territorial entities. So this happens, massive phenomenon in Wikidata, also happens in the kinds of things that we've been doing with foundation ontology. And as Nicole mentioned, he was theorizing about the kinds of types, the sorts of types that there are. So introducing kinds of terminology to say that rules are different from phases and kinds are different from categories and so on. So he was theorizing about the backbone of the taxonomy that would be at the first order level that talks about individuals. So this happens also in the foundation ontology area, and it's not different from domain-specific notions that also do that. So this is, first of all, important phenomenon, happens also with foundation ontology. So I was always keen to understand when João Paulo was talking about kinds and so on. I was also, but these are also things in themselves, right? We talk about kinds as if they're things in themselves. So I was always worried about how do we explain that. And I was always doing model-driven stuff and implementations as, with my computer engineering background, I wanted to have implementations of these things. And, if you know the architecture for specification of languages, you recognize is that you can go for a meta model level and you can have a model level and an instance level. So you might figure out that this is already sorted out in these model-driven language specification architecture. But there are many problems with the approach taken in these architectures. I don't have time to go through the details of it, but since there is a separation between the meta-model level, the model level, and the individual level in these systems, you cannot make very important statements that you would like to. So you cannot talk about ship types. You can only and ships at the same time, because ship types would have to be specified at the language level, and you cannot change the language, the UML language, for example, or OWL to include the notion of ship type. So there are all kinds of workarounds that you need to work with, and not doing what you actually wanted to do, which would be, just represent what, for example, currently is very nicely represented in Wikidata, which is the biological taxonomy domain with, specific animals, like, that lion that was killed in Zimbabwe by some hunter called Cecil. I don't know if you remember, it was a famous death. There is an entry for Cecil in Wikidata, right? Because he's an important lion in the history and so on. Things happen to him that we want to know and remember. And he is a lion, and lions, the species has a number of features. That they are mammals, and a lot of interesting statements in general that can be made about lions. Baron himself made a lot of statements about genes. He was not talking, at some point in time, he was talking about specific genes, but at some point in time in his graphs, he was talking about types of genes, right? So we'll see that in Wikidata, this gives us a lot of trouble, especially for genes. So I was sure that Baron's colleagues have been doing a little bit of creating a little bit of problem for Wikidata. But other of his colleagues, the taxonomists, they are very neatly organizing this knowledge graph into layers, where you have the individual animals, you have the types of animals, and you have the types of animals, and you even have the notion that some of these types have different properties. So they are ranked, and there's some order, there's some structure, there are invariant aspects that apply to the biological domain. There are standards about this, the taxonomists, classification, and so on, where they take this very seriously. They maintain it for hundreds of years in this neat multi-layered structure. This you can do with Wikidata. This is in Wikidata. It's an example actually from the structure. So people can build these models correctly, which is an interesting thing. But they can also get into a lot of trouble by using instantiation and subclassing in very unwise ways. So this is the kinds of examples of problems that we get if we don't have some minimum attention to sanity checking, and if we can use loosely subclassing, which was mentioned before as being a very important primitive, also in Nicholas talk and Nicholas talk, and instantiation. The problem here is that there is no notion, although you can do all kinds of multi-level structures, there is no notion of level that you can use to find out problems in these very large structures. And when instantiation and subclassing is used to do all kinds of wrong things happen, and they happen at scale. So the inference is meaningless if you have these problems. So we need at least a little bit of structure and a little bit of ontology, semantics to fix this. So this is an example that we found out in 2016. First of all, in 2016, we did this first study where we found out that 85% of the taxonomies, multi-level taxonomy in Wikidata had this alarming anti-pattern here, which is if you have a series of classes, or even just two classes related by specialization, and the subclass is also an instance of one of its superclasses. Now, this prevents us from putting the model into levels, because when you do specialization, they are at the same level, but when you do instantiation, they're crossing levels. So you cannot, cut through this graph to establish these neat layers that I was talking about to make sense of the meaning of each of these classes. So here we had the interesting example of an inference that you could like from Wikidata, that Tim Berners-Lee was an instance of profession. It was himself a profession, right? So if profession has some properties, Tim Berners-Lee would have the properties of being a profession. Of course, someone made a mistake in this subsumption hierarchy, confusing the levels, confusing something like a type of professional role. And these statements would be right, like computer scientist is an instance of profession, scientist can be an instance of profession, so on, but not at the same time a subclass of profession, because we cannot make sense of these things when put together. There are in 2010 we redid the study, and there are over 2 million pairs involved in this anti-pattern in Wikidata. So it's a massive. And I will show you that genes are part of the problem, but also part of the solution, because we can show that as there's many other examples. We've written about these examples and explain why we believe that the models are problematic. For example, here, now in current Wikidata, 42% of the direct subclass of statements are also paired with an instance of statement. Imagine this: you take all of the pairs of subclasses, direct pairs, not even those transitive pairs which may be more obscure for people to infer about them. These are the direct ones. When you edit an item, you know that earthquake is declared as a subclass of natural disaster. And even knowing that, user will edit this entry and will add a declaration of instance of to that superclass, even if they see in the same page the other declaration of subclass already. So because they don't understand the differences and implications. So there should be some way for us to augment our intelligence and have very simple tools to tell us that this is wrong. Now this is wrong because obviously they're talking about earthquake as a natural disaster type, right? There are types. We're interested in kinds of rock. We're interested in the types of natural disasters. Wikidata has to be interested in this because they would have a catalog of natural disasters and have to have a catalog of types of natural disasters, which have different kinds of implications, so on, different kinds of properties. So if we try to layer this and we can at least point to the problem, we can also try to come up with a solution. Where is the problem? What is being missed? What do I have to unpack that is currently collapsed in this notion of natural disaster? Because whoever created this entry for natural disaster was talking about types of natural disasters and also specific natural disasters. Specific natural disasters have a specific point in time or interval where they happen, geographical area and so on. But types of natural disasters do not. Earthquake itself, the type of natural disaster, does not have a point in time. And if you believe that what the graph is telling you, you could assign a specific point in time to the idea of tsunami or earthquake itself, not a specific tsunami or a specific earthquake itself. So we have to, even to be able to distinguish this in natural language, we have to use all sorts of devices to disambiguate accent, talking about a kind of natural disaster. Earthquake has a kind of natural disaster, or say that earthquake which happened at some point in time. So it's not a coincidence, obviously, that this problem happens at scale because of the language that we use. Okay, so to tell that that is a massive problem, we ranked all these occurrences of this pattern in 2020, and there you go, the culprits: genes, proteins, pseudogenes, non-coding RNA, biological processes, disease, molecular functions, etc. Now, why? Because there are large databases which are important into Wikidata, of course, but they are important without taking into account these minimum conditions. So if you look at, for example, genes, the genes, whatever they are, the genes that are listed, of course, they're not your specific gene listed on. There's no item for your specific gene listed in Wikidata. So Wikidata is interested in types of genes, right? 96.8% of the instances are also subclasses of genes. So 96.8. So this is just throwing away the meaningful distinction that there is between subclass and instantiation, because if 97% of the instances are subclasses, and 95% of the subclasses are instances. What's going on? This is a conceptual problem at a very large scale. Now, this is a conceptual problem at a very large scale. We can check with a simple Sparkle query, but that corresponds to a theorem in a formalization. So that's now how I want to respond in parts to Enrique's comments. It's there. We are querying this, and we can query this at scale in a very large knowledge graph with simple query. But because there's a theory which backs up, and explaining it in logical terms help us to come up with these queries. I don't have time to explain a lot, and we can talk over this about lunch. There are interesting domains here that I hope we will be exposed to soon, and that Enrico and Nicole are exposed in a very nice way in their regions. And here we have 2,000 occurrences of this, basically 100% of the subclasses of wine are also declared as instances of wine in Wikidata. So, for example, Merlot, or whatever these kinds of varieties, or the specific wines, they are declared in this way. So, losing all the ability for us to distinguish what's the difference in the unit of the. Now, other people have been studying this after our study. Actually, people have been correcting Wikidata after our study. So the Tim Berners-Lee thing is not there, and there are discussions on this on the pages that these people found out this, we have to fix this, and so on. But other problems keep appearing. So over time, this does not get solved. Very interesting. So some folks in Stanford recently analyzed the changes in time, which is our study is based on snapshots. But they studied the changes in time because it is a very interesting source of empirical knowledge, because all the modifications are there. And they realized that there's a very large number of statements of subclass and chain instantiation through time, back and forth, at scale. And also some others have identified that through some clustering techniques that some leaders in Wikidata, some people that modify, more experts, let's say, they change more those declarations of instantiation subclasses. So it's something that people have difficulty with, because only leaders change, but they also change problematically at scale. If you look at the earthquake example that I gave you, and you can go and look at the history of this item in Wikidata, it's very instructive. So all the changes are there. And if you scroll to the page looking for instantiation, you'll see the changes a long time. So instantiation is P31. So in 2016, that was when we published our paper, someone fixed this example by removing the claim of that earthquake is an instance of natural disaster. Good move. That's what we suggested back then. But then someone later on changed and created the claim again 1 year later that it's an instance of natural disaster. I didn't touch mistakes. So someone later created again the claim that it's an instance of natural phenomenon. Here we have these words which could be used in a way that is silent with respect to the order and phenomenon, very general, right? There are some words which defy neat stratification. Here again, someone removed the claim that it is an instance of natural. Good, I was happy in 2018 and I didn't know. Now, these things happen in slightly more complex patterns, all of which can, we can prove that these patterns follow from a basic theory, like this one here. Because if you have subclasses of joint subclasses, subclasses of two classes, that one is the instance of the other, you also have the layering problem. You cannot cut this along the instantiation lines without cutting through specialization. There are 3 million occurrences of this kind of pattern as of the last time we studied this. And you can imagine many other patterns, right? There's a superclass and subclasses that one is the instance of each other, and transitively across, which is actually a problem for us to check in Wikidata, because if you look at the transitive statements that are 60 million pairs of superclass and subclasses. So checking all this is the problem. These queries run, and the Sparkle queries, they end up, timing out or running out of memory and so on. But we made just to show that this can be detected very simply. We made a small one-page application that you can input a specific entity in Wikidata, like wine, which is, I'm very interested in it. And you will see that just by putting this there in a very simple quality panel, you can see that there are 2,000, and some of those here are entities that are simultaneously instances and subclasses of wine, which is a problem for wine. Okay, I don't go through this. So my point is that very little semantics, let's say, very little statement on a meaningful structure for a graph can tell you a lot about what's going on in the representation, right? Of course, if you go a little bit further, use a little bit more theory to introduce other notions, and here in the history of multi-level modeling, there have been power types, different kinds of power types, which make its way into languages and frameworks and so on. You can add some more. So we've been doing this for the UML to come up with syntactic rules, and then nobody needs to be exposed to any formalization after they are, they have a tool with the syntactic rules that check the basic sanity checking for the models. We also had an implementation of this theory, which is called the multi-level theory, in details, which John was involved in the past, and together with Manfred Josfeld, we, where do we put the axioms? The axioms actually become rules in this deductive database, so they end up having implementations in obviously a less expressive format, as Enrico mentioned, very important computational features. So we have that implemented in concept base. We also have in our GUFO vocabulary some rules that can be used and can be checked with the Sparkle queries. We also designed some languages based on that, like the ML2 language in the multi-level modeling community. And we also incorporated some of these sanity checking rules into Augmentation now that you have been hearing some about. To conclude, right in time, a little semantics goes a long way. This motto from Jim Handler. I'd say that some more semantics goes further. A little semantics can also be dangerous, as you've seen. But no semantics, where does it take? And then, of course, the ChatGPT thing has to appear in the next slides, right? So I asked ChatGPT its opinion about Merlot being a subclass of wine or being an instance of wine. So I asked the following: are the following statements inconsistent? Merlot is a subclass of wine, and 2, Merlot is an instance of wine. It says no, the statements are not inconsistent. In fact, they're both correct and can be seen from different perspectives. Actually, people say this a lot, right? We can discuss this later. And then I asked, can they be true at the same time? Now, there was this is a report of the dialogue as it's transcribed, right? I didn't say anything else. First, I asked if they were inconsistent. Right, now I ask, can they be true at the same time? Apologies for the confusion. They're correct. The statements cannot be true at the same time. It doesn't even have an opinion upon this, right? You could at least have, said it, yeah. So then there's an explanation of why this is a problem and so on. And then I asked a further question. Explain the contradiction, right? It just told me that they are inconsistent. I apologize for the confusion. Upon further consideration, I realized there is no inherent contradiction between just so no semantics gets us nowhere. Thanks.